Hey everybody, this is your second lecture on intelligence. This lecture focuses on intelligence tests themselves. We're going to take a look at the learning targets here intentionally. We're going to look at how intelligence is measured. Spoiler alert, it's with tests. But we're going to look at the early ones and how they were developed and how they've evolved to modern times. And then three key ideas that make an intelligence test, or really any psych test, good or useful. Let's get to it. I want to start by defining the word psychometrics. We are finding the metrics of psychology, basically running tests and collecting data about human mental processes and behavior. So it's a subfield of psychology which is strictly focused on how do we collect numbers and data and information that is useful when analyzing psychology principles. One form of psychometrics is IQ tests. Psychometrics encompasses all of psychology, but then IQ tests are specific methods for assessing and comparing mental aptitudes using numerical scores. So that's a big feature of psychology testing is you are trying to find comparisons usually from average, and by average that's what we would consider normal, and then seeing how different people kind of measure up. So let's go to the beginning of intelligence tests and take a look at the history of how they came to be. We're going to start by talking about Sir Francis Galton, who was a British mathematician, statistician, but he was fascinated with trying to measure human qualities. And I'm going to get into why in just a second. But he believed that intelligence is actually quantifiable, meaning it can actually be measured and turned into a number. And that once you do, it is normally distributed, meaning it does form that normal curve. He also created the concept of percentile ranks and correlation, and he used both of those to determine who fell above and below average. So how did people fall above and below the normal masses of most people? He also coined the phrase nature versus nurture and was very interested into how intelligence and other human traits fell into the process of natural selection and survival of the fittest. Fun fact, Charles Darwin, the originator of those phrases, was his cousin. And he founded eugenics. So that kind of makes him a bad guy in the scope of history. But what he thought was that if survival of the fittest in the wild means like the strongest animals or the ones who were best at fighting with the best genes, why wouldn't that work with intelligence? So, wouldn't the most intelligent people or intelligent animals also be the ones most likely to survive? And so he started with those ideas, and he actually thought part of intelligence included reaction time, sensory acuity, like how good your sense of smell and taste and sight were, muscular power, and body proportions. So what's interesting about that is most of those things, a few, but most of those things are not things we would consider part of intelligence today. But he took all of these ideas and he founded the idea of eugenics that we studied, I think, in Unit 0, that basically said if you only let people with desirable traits reproduce, then the best human traits will continue on and on and on. The problem is who is to say what those traits are and whether or not those traits are really the ones that are being passed on, or that other people who maybe aren't deemed quite as worthy couldn't also pass along or create a very worthwhile human being. So eugenics are kind of an ick idea, to put it mildly. Okay, Alfred Binet is our next historical figure in terms of IQ testing. He's a little bit more on the hero side of things. He developed the first standardized intelligence test to fairly identify children who may have learning problems in school. So he was actually commissioned by the French government to create these tests because as they were bringing more and more students into school and they were realizing that students were kind of at different academic levels, they wanted a kind of a quick and non-biased and objective way to determine whether or not a child needed extra supports. So Bonet came up with this test to find a child's mental age. And what we mean by mental age is your level of performance associated with an average chronological age. So a normal 10-year-old would be able to do normal 10-year-old cognitive behaviors. But perhaps if you're an 8-year-old doing 10-year-old level things, that you might be at a mental age of a 10-year-old, you're probably fairly gifted. If you're a 12-year-old doing things that are quite normal or average for a 10-year-old, you might be lower than average. We'll talk about this a little bit more in class, but yes, mental age. Where do you fall on your average cognitive ability compared to your actual birth age? Some things that Benet discovered is that with through his testing, that intelligence is innate. It is something that we are born with, at least to an extent, and that all children have similar intelligence development, but usually at different speeds. Our next lecture is going to talk a little bit more about what else besides simply genetics contributes to the formation of intelligence, and I bet you can make some good guesses. I also want to note that his tests compared to Galton's put much more emphasis into things like abstract reasoning skills and things that we would, critical thinking skills, things that we would actually consider part of intelligence today. An American man named Louis Terman took Benet's test and basically brought it to America. He was a psychologist who worked at Stanford, and he adapted it for U.S. children. And how this was designed is that the examiner would find levels of cognitive development at which the person can answer all the questions, and they would kind of stop there. So what I mean by that is they would give questions, this more along the lines of like everyday problems to solve, explaining analogies, proverbs, describing similarities with sets of words, things like that. And so they would ask these questions that would get harder and harder. And then at some point, when the person taking the test could no longer answer the more and more increasingly difficult questions, they would stop and then they would label that level of cognitive development. And the Stanford Binet test would also result in a mental age. And this is a test that is still in use today. It's evolved, but that phrase, the Stanford Binet IQ test, is still around today. And so let's talk about what they did with the mental age and how it leads to our current day measurement of intelligence. And that is formally IQ, an intelligence quotient. And if you think about what a quotient is in math class, it's the result of division. And so IQ was found by taking the mental age that a child was tested at and divided by their chronological age. We'll play around with the math a little bit here in class, but let's say you have the mental age of a 10-year-old and the child is actually 10, and that would give you 1, and you would multiply it by 100, and that would give you 100. And so you would fit right into average of most people. What I'm going to make you wait on to see in class, although maybe you can anticipate where I'm going with this, is why did this work for children pretty well, but not for adults? We don't calculate IQ this way anymore, but the word IQ is still used as shorthand for your IQ score, or in other words, the score you would get on an intelligence test. And 100 is always normed, like we remake the normal curve, more on that in a moment, to be the average, and then people are either above or below relative to average. IQ tests today are still part of the process to identify students for special education services. There are many, many other factors that go into identifying special services for students, including things like learning disability tests, emotional disability tests, things like that. But IQ is definitely still a large part of that process. And as I said, 100, human average intelligence is always 100. And you might think to yourself, like, always, always? Like, don't people change? Yes, people do change. I'm going to talk about that later and how IQ scores have actually sort of risen over time. But regardless of that, no matter what the scores are in a generation or so, they are always renormed to make sure that the average falls on or around 100. It's just what the 100 represents that changes. I will talk about this more in class and I will apply it to how our AP exams are scored. So you can see what I mean about how the same number can represent something over time, even if people change. And so basically, for the moment, just know that the normal curve or the scaling of IQ scores are re-standardized periodically, with 100 always being the average, but what that 100 represents changes over time. Okay, the most widely used IQ test today is the WAIS test, the Wechsler Adult Intelligence Scale. There is another one, I want to say it's the WCIS. There's another version that is used to test the intelligence of children, but this is the one we are responsible for knowing and we're going to dig into a little bit more. It measures overall intelligence and individual scores. The categories that it breaks things down into, or intelligence down into, is verbal comprehension. So, do you understand words? Perceptual organization. And so you can see this picture, like taking 3D shapes and being able to imagine what they look like when they're flat and vice versa. Working memory, how well you can hang on to information in your head and short-term memory, and processing speed, how fast you can do all of these things. What the WAIS test has found is that normally both or all four of these things average to the general intelligence, overall intelligence, pretty closely. Yet the separate scores give more precise measurement of a person's specific abilities. But if one person is very high or low in one of these and not the others, that might indicate a specific strength or weakness, or perhaps a unique gift or disability of its own. Okay, so let's discuss what makes the WAIS, is that what it is? Yes, WAIS so good, or any other tests, something perhaps like the SATs or ACTs or any other standardized tests that you've ever had to take. What makes it a useful test or not? What are the principles of test construction? The first one is, for a psychometric test to be useful, it must fulfill 4 criteria: standardization, reliability, validity, and it all boils down to fairness. I'm going to talk about fairness a little bit more in the next lecture. Really, 1, 2, and 3 are all meant to make sure that the test is fair. So the first principle is standardization. This is when you administer a test with consistent procedures and environments. So if you think of the last time you took a standardized test, whether for PIAS or anywhere else, the adult or proctor in charge was probably really strict about what you could or couldn't have in the room, what you could or couldn't have on your desk, how you needed to sit. They probably read the rules off of a script to make sure that everybody, no matter where and when they take that test, is being treated fairly, so that there's very strict protocol for administering and scoring the test to make sure that there's no other little biases or confounding variables that get in the mix there. The scores themselves are also standardized or normed, which means recreating that normal curve by pre-testing on a random sample of people and then comparing the actual subjects of your test to that random sample. The random sample is considered the control group. Let me give you an example, it'll make more sense. Do you know, did I tell you? I think I did, but do you know that college students, typically freshmen or sophomores in college, that are taking the course that is equivalent to our AP course, will take that AP exam first? So I don't ask me when or how, but they will take the same test you're going to take, and then most likely, or not most likely, what will for sure happen is the people working on this sort of thing will norm their scores. And that whatever their average is on that test is where students taking that AP course need to reach to get a 3. We're going to put a pin in it right there because I will go through this. I think I already did, but if not, I will go through that one more time in class to make sure you really understand what I mean, both for the sake of understanding the concept of standardization and to understand what you experience with your own AP exam. The second major principle of test construction is reliability. This is to make sure that a test produces consistent, stable results each time it's administered. And this is determined in one of two ways, or I guess technically speaking, it should work in both ways. But the first one is split half reliability. This is when you look for a correlation of the scores on two halves of that test. So let's say you created a test that's supposed to measure happiness, and it's 100 questions. If that's the case, both the first 50 and the last 50 of that questionnaire, of that test, those two scores should correlate. Because if it's a true measure of your happiness, you should be happy in a consistent way throughout that test, or that test should demonstrate or collect data on your level of happiness. And so there should be a correlation between the two halves of that test. You could do it with evens and odds. You could literally split it in half, whatever it is. But that if it's really doing a good job, let's say testing intelligence, both the first half, the second half, the evens and the odds should correlate because it's measuring your intelligence, which should actually be the same the entire time you take that test. The second form is test retest, and this is determined by the results of the same test being given to the same group more than once. A flaw with this is if someone remembers the tests from the first time, they could choose to do better, worse, or actually influence the outcome of the test. So an example here might be to do that same happiness survey, but to do it twice, perhaps 1 month apart, and see if this person is truly happy and they test over and over and over again, or perhaps intelligence if you test over and over and over again, especially far apart, but maybe not too far apart. If it's a reliable test, it's expected, if it's demonstrating your intelligence, that it's consistent when you take that test again later. And the final part of test construction that makes a good test is validity. And I put a star here because this is probably the most important of the three. They're all important, but this is probably the most important. And this ensures that the test actually measures or predicts what it intends to in accuracy and usefulness. You might think, well, duh. Is the AP exam a valid way to test your knowledge of psychology? Would it make more sense to have you draw a picture? Hmm? Could you just draw a picture of your favorite psychologist? Is that a valid way to test your measure your level of mastery of psychology? There are two types of validity that we use, and that is content validity and predictive validity. And they're exactly what they sound like. Content validity means that the test measures the intended behavior or trait. Does this intelligence test actually measure intelligence? And then predictive validity. Does this test predict future behavior or performance on a related criterion, meaning criteria? I don't know why we say criterion. So if you take the SATs as a predictive test on your ability to be successful in college, does it really do that? Does your score on the SATs actually predict how successful you'll be in college? Spoiler alert, it actually does. Talk about that more tomorrow. A test can be reliable, but not valid. I will specifically give you an example tomorrow, not tomorrow, or whenever we have class. But what this means is that a test can produce consistent results. Like if you take a happiness questionnaire over and over and over again, you can get consistent results. Like you always score around at 70%, but it might not, that test still might not be a true measure of happiness. I'll give you some more examples in class, but there's a little one to get you started. I'll give you one that I think will make you go, oh, tomorrow. But I think I do better with it in person than I will over the YouTube here. So there you go. That is lecture on how intelligence tests work. The one last thing I will say is that you will actually take some intelligence tests to actually feel what it's like to do so. All right. See you next time.